Okay, this is notes 2.8, the product rule. So the product rule says that if we are multiplying two functions, in order to find the derivative, we would take the derivative of the first function times the second function plus the first function times the derivative of the second function. Or in other words, f prime g plus fg prime. So notice here we have two functions being multiplied, 8x times sine x. So if we do f prime g plus fg prime, we take the derivative of 8x, which is 8, times g, which is sine x, plus f, which is 8x, times the derivative of sine, which is cosine x. This entire thing would be the derivative. Okay, so now we have 2e to the x times the square root of x, or we could write this as x to the 1/2 power. So we have 2e to the x, because that's the derivative of e to the x, times x to the 1/2 power, plus 2e to the x times the derivative, which is 1/2 x to the negative 1/2 power. Which means we have 2e to the x times the square root of x plus 2e to the x divided by 2 square roots of x. Okay, in this one, before I start, I know I can write this as x to the negative 1. So I take the derivative of f, which is this entire part here. So that's negative 1x to the negative 2. I write out my next function, 2x squared minus 5x. I write out my original function, so plus 1 over x plus 1. And then I multiply by the derivative of the second function, so 4x. Okay, so I could rewrite this as negative 2x squared minus 5 over x squared plus 1 over x plus 1 times 4x. Of course, I could simplify this even further if I needed to, but I'm just going to leave it as is. Okay. Now it says the table below shows values of two differentiable functions f and g as well as their derivatives. It wants us to find h of x, or in other words, the derivative of h of x at 2. Well, we know that h prime of x is equal to 3f prime of x g of x plus 3f of x times g prime of x. And since we're solving at x equals 2, this is 3f prime of 2 g of 2 plus 3f of 2 g prime of 2. So if I look up at the table above, I know that f prime of 2 is negative 2, so 3 times negative 2. G of 2 is negative 1, plus 3 times f of 2, which is 4, and g prime of 2, which is 2. So that means I have positive 2, 6, so this is 6 plus 24, which is 30. And then I do the same for this one. So r prime of x is equal to the derivative of the first function. So this would be 1/2 f prime of x times the other function, 3 minus g of x, plus, writing the other function, f of x over 2 plus 2 times the derivative of the second function, which is negative g prime of x. And since I'm solving at, sorry about the bell. And if I'm solving at negative 5, I have r prime of negative 5 is equal to 1/2 f prime of negative 5 times 3 minus g of negative 5 plus f of negative 5 over 2 plus 2 times negative g prime of negative 5. Well, if I look back at the table again, I will see that this is 4 over 2 times 3 plus 2 plus 3 halves plus 2 times negative 5, which is equal to 2 times 5 plus 7 halves times negative 5, which is equal to 10 minus 35 over 2, which is equal to negative 15 halves.